Let's say you decide to walk to the sun. Just start walking. Never stop, never sleep, never eat. Pure hypothetical. Humor me for a second. How long do you think that takes? Go ahead, guess in your head. Most people say, I don't know, a few years, maybe a decade if they're being generous. Try about 2,000 years. And that's the optimistic version. I want you to sit with that number for a second, because your gut has no idea what it actually means. Nobody's gut does. That's not an insult to you. It's just what happens when a brain built for walking to the next village over gets handed a number the size of the solar system. We're just not built for this. So let's fix that, together, right now. You've heard the number before, probably in school. 93 million miles to the sun. Fine. You nodded, you moved on. The number went into storage somewhere and never really meant anything. And that's the problem. Hearing a number and feeling a number are two completely different experiences, and your brain, honestly, cannot feel this one on its own. It needs help. So here's the help. You know what it feels like to walk around the entire Earth. Well, nobody's actually done it non-stop, but you've heard that number too. Roughly 25,000 miles around the equator. That already sounds like an enormous trip, doesn't it? A lifetime achievement. Something you'd tell your grandkids about. Now take that same distance, walking clean around the whole planet, and do it again. And again. And keep doing it over and over, thousands of times in a row. And you still haven't covered the gap between here and the sun. 93 million miles isn't just bigger than walking around the Earth. It's bigger by a margin that makes around the Earth look like a walk to the mailbox. Let's do the actual arithmetic, plainly, the way I like doing it. No tricks, just the numbers laid out where you can see them. Average walking pace, nothing heroic, just a normal human stride, about 3 miles an hour. No stopping, no sleeping, which is, of course, physically impossible for an actual human being, but stick with me, because the number itself is the whole point here, not the biology yet. 93 million miles, divided by 3 miles an hour, get you about 31 million hours of walking. Divide that by 24 to get days. You're at roughly 1.3 million days. Divide that by 365 to get years, and you land close to 2,000 years. 2,000 years. Walking. Non-stop. Say that out loud and actually think about what fits inside 2,000 years. That's longer than most religions have existed. That's longer than most languages spoken today have been spoken in their current form. That's not a long trip. That's a civilization's worth of time, compressed into a single unbroken walk that never lets you rest. Now here's where the question actually gets interesting, more interesting than the arithmetic even. Say somehow impossibly you make it. 2,000 years of walking, no rest, ever. Where exactly do you plant your foot down and say, I've arrived? Go ahead and picture the sun the way you normally do. A solid yellow ball, like a giant beach ball hanging in space, with a clear edge you could touch if you got close enough. That picture is wrong, and it's wrong in a way that actually matters for this thought experiment. The sun doesn't have a surface the way the Earth has a surface. What we call the sun's edge, the photosphere, the layer that gives the sun its visible boundary in every photo you've ever seen, isn't solid ground at all. It's just the layer where the plasma finally becomes thin enough, transparent enough, for light to escape and travel outward to your eyes. Below that layer, it's still sun, still plasma, just thicker, hotter, denser plasma all the way down. There's no floor. There was never going to be a floor, not at the surface, and not at any point before it either. So think about what that actually means for your 2,000-year walk. Long before you'd get anywhere near that hazy visible edge, you wouldn't be walking anymore because you wouldn't be a solid object anymore. You'd be vaporized, then ionized, stripped down to bare charged particles, no longer anything you'd recognize as a body. Walking to the sun isn't just an impossibly long trip. It's a question that doesn't fully make sense at the very end of itself. You're not walking toward a place the way you'd walk toward a house or a mountain. You're walking toward the exact spot where matter stops behaving like anything you'd call solid at all and just keeps going, thinner and thinner, or denser and denser, depending which direction you're headed, with nothing you could ever call arrival. Let's push into the honest physics a little further, because this is where it gets properly wild, and I don't want to skip past it. You wouldn't even need to reach that hazy, visible edge to die. Not close. somewhere around a few million miles out, which sounds like a lot until you remember the whole trip is 93 million miles, the heat and radiation would already be lethal. Not uncomfortable, not bring sunscreen lethal. There is no suit, no material, nothing we've built or could build that shields a human body from what that environment does to you at that range. You'd be cooked from the outside in long before you got anywhere close to the part everyone pictures as the sun. And here's the part that genuinely surprised me the first time I actually laid the numbers out. Most of that 2,000-year walk isn't hot at all. It's the opposite. Deep space between here and there is cold and dark and mostly just empty. Mercury, the closest planet to the sun, sits at roughly a third of the total distance from Earth. So picture your walk. You'd cross the entire orbit of Mercury, the whole way around where that planet circles the sun, and you'd still have 2/3 of the trip left to go. Most of the walk, the overwhelming majority of those 2,000 years, happens in cold, quiet, unremarkable space. Nothing dramatic going on at all. And then, right at the very end, over just the last sliver of the journey, everything flips. The temperature curve doesn't rise gently. It spikes fast, exponentially, in the final stretch. Almost the entire walk is silence and cold. And then, all at once, right before the end that was never really going to be an end anyway, everything changes violently. Now, here's what I actually think about every time I run this thought experiment in my head. And I do run it, more than you'd guess, because I find it clarifying rather than just fun. It's not really about walking. Nobody's walking to the sun. That was never the point. The point is what happens when you force your intuition, the part of your brain that's used to distances like down the street or across town, to actually meet a real number instead of letting that number float by as an abstract fact you half remember from a textbook. Because here's the thing that should genuinely humble you. 2,000 years of non-stop walking, no rest, no food, no sleep, an impossible journey by any measure, that gets you to the closest star we have, the nearest one. The one sitting right next door, cosmically speaking, close enough that its light warms your actual skin on an actual afternoon. And every other star you've ever looked up and seen twinkling in the night sky is trillions of times farther away than that. Trillions. Not double, not 100 times, trillions. The sun, which felt like an unreachable, impossible distance a minute ago, is basically standing right next to us on the scale the rest of the universe operates on. So here's where I want to leave you, because I think it's worth sitting with rather than rushing past. Next time you feel the sun on your skin, some ordinary afternoon, nothing special about it, remember that the warmth you're feeling crossed 93 million miles of empty space in about 8 minutes, traveling at the speed of light, effortlessly, the way light always travels, without struggle, without cost. And it would take you 2,000 years of walking non-stop, without a single moment of rest, without food, without ever once being allowed to stop moving, just to almost get there. Not even all the way. Almost. That gap between how effortlessly the light arrives and how impossible the walk would be, that's not really a math problem, even though we did the math to get here. That gap is the actual size of the universe, finally shrunk down small enough, for just a moment, for a human body and a human lifetime to actually feel it. Most of the time, the universe is too big to feel anything about. It's just numbers. But every once in a while, if you do the arithmetic honestly and let it land, you get a genuine physical sense of just how much space is really out there, and how strange it is that light crosses it so easily, while we, walking, barely could.